I really hope that you are doing great. Welcome to today's class. It's our third lesson on Statistics 1, whereby we are looking at our example number 3, which reads that the table below shows daily wages paid to casual workers by a certain company. So we have the wages in shillings, which are representing our classes. Then, of course, number of workers are simply representing our frequencies. So in part A, we are told to draw a histogram to represent the above information. So remember, in our previous class, we did give two scenarios when you are drawing a histogram. The first case, we looked at when the class width, or what we are calling the class intervals, or the class intervals are uniform. Intervals are uniform. So when they are uniform, we said a histogram is drawn with frequency against upper class limit. So we plot frequency against upper class limits. The upper class limits, that is whenever the class width is uniform. Then part B is when the class width, or what we are calling the class intervals, or when the class intervals are not uniform. They are not uniform. Then for such a case, we usually plot what we call frequency density against upper class limit. So here we plot frequency density against upper class limits. So what determines what you are going to put on your vertical axis is actually the uniformity of the class width or the class interval. For example, you remember in example 2, we actually looked at a case scenario whereby we had classes ranging from maybe 30 to around 34. We also had another class was 35 to 39. Then we had 40 to 44. So actually we saw that for this particular case, for example here the class width was 34.5, then minus 29.5, which was giving us a class width of 5. Then this was 39.5, then the lower class limit was 34.5, which was also giving you a class width of 5. So for this case, the class width were uniform, that is, they were all 5. That is why we used frequency on the vertical axis against upper class limit. So for our case scenario, we need to check the class width and see whether it is uniform so that we can determine what will be on our vertical axis. Therefore, I'm going to add another row here for the class width, So to find the class width, we'll simply be taking 150 divided by, that is minus 100. Remember, when you are given classes, for example, the classes of 100 to 150, then the next class is 150 to 200. Then for these classes, we don't add or subtract 0.5. That is whenever we are finding the upper or the lower class limits respectively. The reason is because the upper class limit of this class, it becomes the lower class limit of the next class. Therefore, they are continuous. That is, all values are defined for this particular case. But for example, in a class whereby you have 30 to 34, then you find the next class is 35 to 39. For this particular case, there are values that are not defined. For example, values from 30, that is 34.1, 0.2, 0.3, 0.4. Yeah, those values are not defined. That is why we include the 0.5, so that the upper class limit of this one becomes 34.5, which is the same as the lower class limit of the next class, which will still be 34.5. But when the upper class limit of this class becomes the lower class limit of the next class, and so on and so forth, then we don't add a 0.5 on the upper class limit, neither do we subtract the 0.5 from the lower class limit. Therefore, to find our class width, we'll simply be subtracting the upper class limit minus the lower class limit. So this will be 150 minus 100, which gives you a class width of 50. Then this one will be 200 minus 150, which gives you a class width also 50. Then 300 minus 200, you're going to get a class width of 100. Then 400 minus 300, you're going to get a class width of 100. Then 600 minus 400, the class width will be 200. So you can see clearly that for this case, the class width is not uniform. Why? Because here we are having 50, 50, then here we have 100, 100, then we have 200. For this case, all the class width were actually 555, so they were uniform. That is why we were plotting frequency against upper class limit. But because for this case, the class width are not uniform, some have a class width of 50, others 100, others 200. That is why you are going to plot the frequency density against the upper class limits. Therefore, that means we need another row for the frequency density, because that is what we'll be plotting on our vertical or the y-axis. Therefore, we need to find the frequency densities. Therefore, I can add another column for the frequency density. Density. So to find the frequency density is usually given by the formula frequency density. Frequency density is usually given by the formula frequency. You simply find the frequency, then you divide with the class width. Frequency divided by the class width. So this is the formula that we use to find the frequency density. For example, we can start with the class running from 100 up to 150. Its frequency density will be, the frequency in that class is 160. So this will be 160 divided by the class width in this class is actually 50. Therefore, if you take 160 divided by 50, you are going to get 3.2 as your frequency density. So this is 3.2. So this will be 3.2 as our frequency density. We move to the second class of 150 up to 200. The frequency is 120 divided by the class width is 50. So 120 divided by 50, you are going to get 2.4. So the class width in this case is actually 2.4. So we have 2.4. The next class will be frequency is 380 divided by 100, which is going to give you 3.8. The next class is 240 divided by 100, you'll get 2.4. Then the next class is 100 divided by 200, which will give you 0.5. So these are our frequency densities. Now, once we have the values of the frequency densities and also the upper class limits, we can actually draw what we call our histogram. Therefore, to draw our histogram, we need two axes. We need the vertical axis and also the horizontal axis. Therefore, I can put my vertical axis through this point. Then I'll let my horizontal axis to actually move through this particular point here. Then, of course, I'm going to make them continuous. Let me make this one continuous. I also make it on this other side to be continuous. So we said that when the class width is not uniform, we plot frequency density. So on this axis, we need frequency density on the vertical axis. Frequency density, usually abbreviated as FD, then against the upper class limits. The upper class limits. The upper class limits. Then the upper class limits in this case are represented by, remember the classes are coming from the column which had the wages. So you can talk of the upper class limit or simply put wages in shillings. They were wages in shillings from our original question there. So those will be our columns. Then we need to indicate the values. So for the frequency density, the largest value is actually 3.8. Therefore, I can start with a 0 at this particular point. So this will be 0 here. Then after 5 boxes, 1, 2, 3, 4, 5, I'm going to have 1. Then 1, 2, 3, 4, 5. I'm going to have 2 at this point. Then 1, 2, 3, 4, 5. I'm going to have 3 at this point. Then 1, 2, 3, 4, 5. I'm going to have positive 4. So remember, I don't need a value greater than positive 4 because the largest frequency density is 3.8 in the given case. Then for the upper class limits or the wages in shillings, we usually plot them based on the smallest class width given. For example, if you check the class width, the smallest is actually 50 because this one is 50, 50, 100, 100, and 200. Therefore, our smallest class width is 50, so that is what we are going to use to plot. Then if we check our classes, the first class runs from 100 to 150. So that means the class that will come before this, its upper class limit will actually be 100. Just like 150, which is the upper class limit of this class, becomes the lower class limit of the next class. Upper class limit of this class 200 becomes the lower class limit of the next class. Similarly, upper class limit of 300 becomes the lower class limit of the next class. So it means if 100 is the lower class limit of the class running from 100 to 150, it means the class that will come before that, its upper class limit will be 100. Therefore, the first value that I'm going to plot here on the horizontal axis, I'm going to plot 100 because that is the value that I need. Remember, for this case, I'm not adding any one class before because I'm not asked to draw a frequency polygon on it. So we only add other classes before and another class after when you're told to plot a frequency polygon on top of a histogram, because that one usually needs the midpoints. So if this is 100, so I'm going to use the smallest class width, so I'm going to be varying with 50. So after 5 boxes, 1, 2, 3, 4, 5. So this will be 100 plus 50, you'll get 150. After 5 boxes, 1, 2, 3, 4, 5. So this will be 150 plus 50, you are going to get 200. Then 1, 2, 3, 4, 5. This is 250. 1, 2, 3, 4, 5. This is 300. 1, 2, 3, 4, 5. This is 350. 1, 2, 3, 4, 5. This is 400. 1, 2, 3, 4, 5. This is 450. 1, 2, 3, 4, 5. This is 500. 1, 2, 3, 4, 5. This is 550. Then lastly we have 1, 2, 3, 4, 5. This is 600. So remember, our largest class limit is actually 600. That is why I'm going to stop at that point. So the key thing is you use the smallest given class width to vary these ones. For example, if the smallest class width for this case was 100, then it means from 100 the next value will be 200, 300, 400, 500, 600, that way. So you use the smallest given class width when you are varying the values on the horizontal or the upper class limit axis. Of course, after that I'm going to plot the values. I can use a different ink here so that you can see the differences clearly. So I'm going to start with the first class is running from 100 up to 150, then its frequency density is 3.2. So 100 up to 150, the frequency density is 3.2. So 3.2 will be, so this is 3.0, so this will be 3.2 here. So our 3.2 is going to lie through this particular point here. Then the next class is 150 to 200. 150 to 200, the class width is the frequency density is 2.4. So I need 2.4. So this is 2.0, 2.2, then 2.4 will be here. So this class is going to lie here at 2.4. Then the next one we have 200 to 300. The frequency density is 3.8. So 200 to the 300 is here. So 300 will go up to 3.8. 3.8. So this is a 3.0, 3.2, 3.4, 3.6, 3.8. So our 3.8 will be here. Therefore, I'm going to connect these two up to 3.8. So our 3.8 should be somewhere here. So I'm going to connect this one with that bar here. Then the next class is 300 to 400. I have 2.4. 300 to 400. 400 is here. The frequency density is 2.4. So 2.4 will be, this is 2.0, then 2.2, then 2.4. So this will be our 2.4. So the 2.4 is here. 2.4. yeah, that will be our 2.4. Then the last class is running from 400 to 600. The frequency density is 0.5. 400 to 600, the frequency density is 0.5. So 0.5 will be a half of 1. So this one should lie through this point here. They are half of 1. So 2.5 boxes from 600. So from here I have 2.5 boxes. 2.5 boxes up to this point here. Then I'm going to connect these two. I'm going to connect these two here. So that is what we are calling our histogram for this particular case. Remember, you can also choose to shade it or leave it that way. So it's not a must that you shade, but you can shade if you wish. Let me shade mine. You can shade it so that to make your work presentable, but remember, it's not a must. It's not a must to shade. You can just leave it the way it is. Let me shade mine this way. Yeah, so that is my shading. That is my histogram. Then we move to part B of the question. We are told to state the class in which the median wage lies. So if you want to find the class in which the median wage lies, you are going to use the area. You find the total area for the given set of data, then a half of the area should give you the median. Therefore, I'm going to introduce another row here for the area of each bar. Remember, if you want to find the area of a rectangle is given by length times width, because I can name these my rectangle A, rectangle B, rectangle C, D, then E. So we have 5 rectangles. So area is given by length times width, for which in this particular case, our width will be the class width. That is why we are calling it the class width. Then the length of, for example, this rectangle A, the length will be the frequency density. So that means area is equals to frequency density, the frequency density then multiplied by the class width. So area is given by frequency density times the class width. Therefore, the area for the first bar, remember this one represents the area for A, for B, for C, for D, then for E. So the area for the first bar, you are going to take the frequency density, which was 3.2 at this particular point. So 3.2 times the width will be 100 minus that is 150 minus 100, which is giving you 50, which is the same as saying taking 50 times 3.2. So if I take 50 multiplied by 3.2, I'm going to get 160. So the area for part A is 160. The next one will be frequency density times class width. The class width is 50. Frequency density is 2.4. So if I take 2.4 multiplied by 50, I'll get an area of 120. So the B has an area of 120. Then the next one will be the class width is 100. Frequency density is 3.8. So this will give me 380. That is 100 times 3.8. The next one will be 100 times 2.4, which is going to give me 240. Then the last one will be 200 times 0.5. I'm going to get 100. Therefore, we need to find the total area so that the midpoint is going to lie at a half of that particular area. Therefore, our total area, the total area will be, we are going to add the areas for A, B, C, D, and E. So total area will be 160 plus 120, then plus 380, then plus 240, then you also add 100. So let me add 160 plus 120, then plus 380, then plus 240, then plus 100. I'm going to get a total area of 1000. So this is giving me 1000. So we are told the class in which the median lies. Remember the median. So the class in which the median is supposed to lie at a half of n. So in this case will be a half of the total area, which is going to give us a half of 1000, which is going to give us an area of 500. So we need to find the class in which the area of 500 lies. That is what will represent what we are calling our median wage, or the class in which the median wage lies. So I'm going to add the areas that of course I'm given. So we can start with the area for point A is 160. Then I'm going to add the area for B is 120. So 160 plus 120, this one will give me 160 plus 120. I'm going to get 280. So I can add another one. So 280, if I add 280, if I add 380, if I add 380, this one will give me so plus 380, it will give me 660. So that one is far much greater than 500. So that means we are supposed to stop at this particular point here. So we are supposed to stop at 120. So remember, 160 plus 120 was giving us 160 plus 120. This one was giving us 280. So this one gives us an area of 280. But remember, we want an area of 500. So 280 is accommodated by this bar and this other bar here. So it means because 280 is close to 500, but it's less than 500, so it means our median will lie in the next class. So the median will actually lie in bar C, because up to A and B are giving us 280. Then if you add the total area for C, it's giving us 660, which is far much greater than 500. So this one suggests that the median is lying in this particular class that is having C. So the C, it means our median class will be 200 to 300. Therefore, our median class, the median wage lies in the class of C, which is 200 to 300. So this is where our median wage lies. So that is the class in which the median wage lies. Then Roman 2 of part B is telling us draw a vertical line in the histogram showing where the median wage lies. So a vertical line in the histogram showing where the median wage lies. Now we know that the median wage is at an area of 500. Therefore, what we are going to do is to find the extra area that is remaining in this particular bar. So to find the extra area, you will take 280, then you subtract from 500. So let me subtract those two so that we find the area that is remaining in the second bar. So if you take 500 minus 280, you are going to get 500 minus 280. I'm going to get 220. So we have a remaining area of 220 in this particular bar here. So we need an area of 220 in this particular bar to take us to our median. So because I don't know the length, I'm going to let the length through this particular bar that will give us that area of 220 to be x. Then remember, so that means I'm assuming my median will lie through this particular length of x. Then remember, the area that I'm remaining with in this particular bar C is actually 220. So I'll say 220 is equals to length times width, which will be 220 is equals to, the length is so the width is actually x, then the length will be the frequency of this particular class, that is the frequency density of this class, which was actually 3.8. So it will be 3.8 multiplied by the width in this particular class is w, which is actually the x that we have indicated here. So it means the value of x will be 220, then of course divided by 3.8. Therefore, our x will be 220 divided by 3.8 is going to give us 57. So I'm getting my x is 57, 57.89. That is correct to four significant figures, 57.8989. So this is the value of x. So I need this value of x in this particular bar here. So where will our 57.89 lie in this particular bar? So we need to calculate the specific box that the 57.89 is actually going to lie. So our 57.89 is going to lie through, we can actually calculate the number of boxes. We can calculate the specific number of boxes that we are going to need in this particular bar. So I'm going to say from 200 up to 300, I'm having 10. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So I'll say if 10 boxes are representing, so 200 up to 300, that difference is 100. If this one is being represented by a width of 100, what about our width of 57.89? So this will be over 100, then multiplied by 10 boxes. So this one means, of course, 0 and 0 will cancel out. So it means we are going to count 57.89 divided by 10. So the 10 will just shift the decimal here. So it means we need 5.789 boxes. So we need this number of boxes in this particular bar having the C to take us to our median. So this one, correct to 1 decimal point, it's roughly 5.8 boxes. So we need 5.8 boxes here. So let me count the boxes. So I have 1, 2, 3, 4, 5. So I need 5.8. So roughly 5.8 will be somewhere here. Therefore, let me connect it. So you can use your ruler to draw the line. So 5.8 will be somewhere here. It will be somewhere here. 5.8. Let me pick my ruler from this other end. So I need 5.8. Let me pick my ruler. I can rotate it so that I can draw the dotted line. So my 5.8 will be somewhere here. I can reduce its length. 5.8. It is actually somewhere here. So I need to draw it through this particular point here. Ensure it is vertical. Then after that, you can actually draw the line. Maybe let me use a different inking here. So the line will be here. This will be the line representing our 5.8 boxes. So these are 5.8 boxes. So this is our this is where the median lies. So this is what we are calling the vertical line. Vertical line. So this is our vertical line, which is representing the median. So this is where our median lies through the 5.8. 1, 2, 3, 4, 5. Yeah, 5.8. So I'm hoping you are able to see the procedure of how we got that line. Then part C of the question, we are told that using the histogram, determine the number of workers who earn 450 shillings or less. So the number of workers will simply be equal to the area below the 450. So the area below the 450, let me create some working space here. So we need to find the area below. So we are told using the histogram, determine the number of workers who earn 450 or less per day. 450 or less. So remember our 450 is at this particular point. Therefore, we are simply going to find the area of this part. So the area of this remaining bars will actually be the number of workers. Therefore, for part C, we are going to have, so we'll add the area of A. So this will be the area of A, then you add that of B, you add that of C, then you add the area of D. Then of course within E, you are only going to take the area of this small part here, this small part here. So this will be area A. We had already computed. Area A was 160, so we'll take 160 plus area B is 120, then plus the area of C. The area of C is 380. Then the area of D is 240 plus 240. Then we are going to add, remember we have added up to the area of D, so we need the area of this part here. Of course, area is length times width, so the width is 450 minus this distance here, 450 minus 400, which is actually 50, then multiplied by the length. The length is the frequency density of this particular bar, which was 0.5, so multiplied by 0.5. So this one is going to give us, so let me take 160, I add 120, then I add 380, then I add 240. So these two are going to give me 900, so it's 900 plus 50 times 0.5, I'm going to get 25. Therefore, this will give us 925. So determine the number of workers. So 925 workers will be earning 450 shillings or less per day. So that's a question worth 10 marks. So that marks the end of our today's class. So thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.